Okay, here's today's enrichment lesson. Now what we have to do is solve for x, and it's a proportion and it's got two ratios. So I can't cross multiply and divide, so with two ratios I know that timesing those two together equals timesing those two together. A, B, C, D. Okay, that's a B. Okay. So I will take A times B on this side, C times D on the other, because the products always equal each other. So 1 times 8, and C is x, and D is x minus 2. Okay, so 1 times 8 is 8, and then here I distribute the x. That's going to give you x to the second minus 2x. Okay, now I have two solutions for the x variable, because it's to the second power, but there's another x that I can't combine with it, so I need a 0 on this side of the equation. So I'm minus 8, then just put that after the, so I have 1x to the second minus 2x minus 8 equals 0. Okay, three terms, GCF and T. And we studied that concept first semester, taking the A times the B is always equal to taking the C times the D, because if you have one, don't write this down, but if you have 1/2 and 5/10, well, that's 10 and that's 10, so they equal. GCF would just be 1, so we don't do it. Then I find the AC product 1 by negative 8. Okay, so I definitely want to subtract minus to get to negative 2 with the factors. 2 and 4 does that. Okay, so negative 4, and the negative 8 means you got to have positive 2, because that times that's negative 8, and that plus that combines to make negative 2. Okay, now my A is 1, so we get rid of the 1 and just write it as x plus 2 times x minus 4 equals 0, and I have my two factors. So I minus 2, that gives me negative 2, and then I add 4, and that gives me 4. So sometimes a proportion for a variable has two possible solutions. Doesn't always have just one. Okay, now the next thing is not as much work as I just did. Okay, you do have some practice problems, but you want to watch all the problems here. Okay, it doesn't entail as much work, but it's a little bit harder to grasp. Okay, what the heck? I have to solve for x, and it's a proportion, but it's got three ratios. So that throws out A, B, C, D. You can't use that. So what you need to do with the three ratios is first off rewrite the problem by making the lines a little bit wider. And then 1 has no operations with it on top, so that's 1, 2, nope, 1, nope. And on bottom, no operations within just the bottom, 2, x, and x. And my job is to rewrite this so all the denominators are the same. That's called finding the LCD. Okay, now you're only concerned about the bottoms. You don't care about what's on top. So I have a factor of 2 here, a factor of x here, and a factor of x here. Well, I already wrote x down. I don't write it again. So how many 2's are in the denominator of the first ratio? 1. How many 2's are on the denominator? I don't care about the top. I care about the bottom. There is none there. And there's none there. So we got to raise those 2 up so they each have 1. So I times the 2, and I also have to times it to the top then. Times the 2, times it to the top. Now they all have 1, 2. But you also got to make sure when you bring that factor in, you also bring it to the top. Now x, I have 0, I have 1 and 1, okay? So I got to get, so that has 1 as well, okay? So times x, and just put x. You don't need to write the times on top, just put the x. Now the bottoms are all the same, so that allows you to just forget about them, okay? And you can solve that equation. So you got 1x. 2 times 2 is 4, 1 times 2 is 2, and then you just subtract your 4. And x is negative 2. There's no, I mean, you don't have to divide it by 1, okay, because it would still be negative 2. So, pretty quick. Okay, likewise on the next one, the denominators are all different, and it's three ratios. So, the top, I don't have any operations. 1, I mean, you have operations, but they're between the fractions. They're not on top of a fraction. Okay, and on the bottom, I want that written as 2 times x, and then 10. And then that one we write as 5 times x. Okay. And I got to figure out an LCD. So in the first denominator, I have a factor of 2. And it kind of separates the 2 from the x. And a factor of x. I have a factor of 10 on bottom on the second one. A factor of 5. And then another factor of x. Well, I already know I have x. I have to deal with x. So LCD, so you got 2, so there's 1, 0, and 0. So we got to get these so they each have 1, 2. So I'm going to multiply by 2, multiply by 2, and then multiply by 2, multiply by 2. Now they all have 1, 2 on the bottom. Now how about x? We got one factor of x here, none here, and 1 here. So we got to raise that one up so it has 1. So I just x and x. Okay, how about 10? 0 there, 1 here, and 0 here. So these have to be raised so they have 1. So times 10, times 10, times 10, times 10. And then finally the 5, okay? Everything's good except that has a 5 and these don't. So 0 factors of 5, 0, and 1. So we raise those up so they have 1 factor of 5. So times 5 times 5 times 5 times 5. Now the bottoms, through all that crap, they're identical, okay? And I can cross them out. Now, what's 1 times 10 times 5? Well, that'd be 50. What's 3 times 2 times 5? Well, 3 times 2 is 6. 6 times 5 is 30, so that'd be 30x. And over here, 1 times 2 is 2, times 10 is 20. And then you just solve for x. You subtract 50, which is negative 30, divide by 30, divide by 30, and you get negative 1. Okay, now there is another way to do this problem. You could just put x and x so they'd all have an x, and then you could times that by 5, and that by 5, and that by 2, and that by 2, then they'd all have 10x. But I get the same answer regardless, okay? So there's no better way to do it, okay? Like 2, 10, and 5 have a least common multiple of 10, so if you times 2 times 2 times 5 times 5, then you have a 10 in all the places, okay? And then x, but I like to list them out separately. That's just my preferred way. Okay, and then the next one, got to have a now one thing, if you have subtraction, make it plus and make just the numerator negative. Okay, so you got 5, negative 1, and 1. Okay, you got 12. You need to write your operator, 2 times x and 3 times x. Okay, so LCD, well, I got a factor of 12 here, a factor of 2 here, a factor of x, factor of 3, and then another factor of x. So it's kind of like the last problem. So 12, I have 1, 0, 0. Okay, so we need to raise those up so they have 1. So I need to go here and times 12, times 12, times 12, times 12. Okay, so 2, I have 0 factors here, 1 here, and 0 here. So I need to raise those up so they have 1. So times 2 times 2 times 2 times 2. Okay, x, I got 0, 1, and 1. Okay, so he's got to get with the program and have an x. So times x times x. And then 3, okay, that's a 2 there. I have 0, 0, and 1. Okay, so we got to raise those up so they have 1 factor of 3. Okay, now the bottoms are all the same. Okay, so 5 times 2 is 10, and then times 3. Remember, multiplication is commutative. You can do it in any order. That'd be 30x. And then negative 1 times 12 is negative 12 times 3 is negative 36. Write minus 36 if it's negative. And then that ends up being 24. And then you just add 36 which is 24 plus 36 is going to be 60, and then I divide by 2, and x is 2. Now, like on the last one, you could have said, okay, I need an x here and an x here, then they'd all have x. And then 12, 2, and 3, you can get them all to 12 by timesing 6 and 6 and 3 and 3. And sorry, 4 and 4. You'd have the same answer. It's just a different way of doing it. Okay, next one. So 3, 8, and 21. 8, put your operator, 2 times x, and then 3 times x. So your lowest common denominator. Okay, it's really not your lowest common denominator. It's just a common denominator. Okay, so you would be just CD. Because up here I didn't get the lowest common denominator. I got a common denominator, but not the lowest. The lowest would have been getting them all to 12. Okay, so I've got 8, and then 2, and then x, and then 3. Okay, and then there's another x. So 8, I got 1, 0, 0. So we got to have those both be 1. Okay, so I times 8 and times 8 times 8 times 8. Now everything has a factor of 8. 2, 0, 1, 0. So I got to multiply by 2 here and here, and here and here. Okay, x, 0, 1, 1. So I'm going to need to multiply by an x factor here and here. Then 3. 0, 0, 1. Okay. Then times 3 times 3. Remember, you don't care if it's already on top. It's on bottom. Now, if you look at your bottoms, they all have the same thing. Out of order, but still the same. Okay, 3 times 2 is 6. Times 3 is 18. 18x. 8 times 8 is 64. And then I take 64 times 3. 192. Then I take 21 times 8 times 2, giving me 336. So I subtract 192. $144, and then I divide by 18, and 144 divided by 18 is 8. Okay, x equals 8. Now again, what you could have done here is x at and x there, and then 8, 2, and 3, you would get them all to 24, as if you did it the other way. Okay, okay, now I have another one here on this next one. Okay. Now, when you have whole numbers, you want to underline them so they all have fractions. Now, this one has 4 terms, okay, but I attack it the same way. Blank plus blank equals blank plus blank. Okay, so again, 7, 3, 7, and 9. Nothing, leave that empty. Don't put a 1, okay? You're convoluting the problem. And then empty. So when I do an LCD, that's empty. That's x. That's x, so I already got that, and that's empty too. So really, it's just x. So I'm looking at 4 of them this time. Okay, so I have 0, 1, 1, and 0. So we need to raise these two so they have 1. So I put an x here, and then just there. X here, and then here. Now the bottom can be discarded, and I go about my business. So I got 7x plus 3 on this side, 7 plus 9x on this side. So you just combine, get your x's together, subtract 7x. That's 3 equals 7 plus 2x minus 7. Negative 4 equals 2x, divide by 2, and that's negative 2. Okay, boom. Okay, when you're doing these on your own, remember, underline that, leave it empty. Okay? Remember to put the times dots on the way down.